This is Qt 5 Design Patterns Section 6. This section deals with threading. Now, threading typically strikes fear in the heart of even advanced programmers because it is so complex and so problematic. We're going to look at how you can inherit a Qt thread, move a Qt object to a different thread, work with the thread pool, work with Qt concurrent, and do threading in widget and QML applications. All right, everybody, let's talk about threading. Now, threading in Qt is hard. I mean, threading anywhere is hard, but Qt makes it hard because there are multiple ways to do the same thing. Now, we're going to start with what I call the Java style way of doing it, where you actually inherit a thread. And this is what I mean right here. We're going to inherit Qt thread. It's not the best idea, but it can be done. This is very similar to Java style, and you see a lot of Java programmers coming over to C++ and Qt doing it this way because this is what they've done in Java. And I dare say .NET as well, although .NET has a different way of doing it. I want to note right up front, this is not the best idea. It can be done. And there is, I want to say almost down to a religious level, disagreement, even among Qt developers, internal people who work for the Qt company, that disagree on how this should work. So we're going to explain a little bit of that on the end. But right now, let's worry about inheriting Qt thread. So I've got my class here, and don't zone out. I know we've made this very simple, but we're going to do something a little different with this. So we're going to say include Qt thread, and I want to inherit Qt thread. So we're going to change that from Qt object to Qt thread. Do that here as well. So what have we just done? Well, we've changed my class from a Qt object to Qt thread. So now we can go in here, insert virtual functions, and we can actually add in run. This is what Java programmers love to do, and I don't mean to pick on Java folks, other languages do it as well. It's a pretty standard pattern. You actually inherit the thread and then you override the function. So what happens under the hood here is, well, you guessed it. Let me grab some code off the screen. The run function runs in a separate thread. You notice I've got these current threads so we can see exactly what's going on here. The problem with this method is it really breaks the spirit of the QThread class. This will run without problem, but you could very easily break this thread by doing something in this run function. For example, this little line here could have drastic consequences to your application if you're doing some sort of intensive work that should not be delayed. There's a billion different scenarios that could happen. But unfortunately, this will compile and run, as we're about to see. And you'll even see this in some of the Qt documentation. That's right, so even the documentation is going to use this way. It's very frustrating to get people out of this mentality here. So coming videos, we're going to show you better ways, easier ways of working with threads, but we're going to just demonstrate this. So we got QDebug, QObject, QTimer, QThread. Why do we have QDebug in there twice? Let's get rid of that. QSharedPointer, and of course our trusty little my class, our Swiss Army knife of these tutorials here. Let's go ahead and make a timeout function. So we're going to work with a timer here. And so we need to have a timeout. I always like putting my programs in timeouts. It's like they've been bad or something. You're in a timeout. And I need to get a little ahead of myself here. Let's call this thread. And QTimer. Let's turn this into a pointer. All right, so if not, and let's say no thread, then return. If not timer, then we're going to go ahead and return. And let's just make some really, really simple code just so we can see what's going on here. So if the thread is running, don't really need the and true or equal true, and the thread is finished equals false. at which point we should actually be running and doing something on that thread. Now I'm just going to grab this and just kind of flip this around. And there are much better ways of doing this. I'm just, in case somebody's not the best at C++, they're still kind of in entry-level land, which they shouldn't be. I want to make it painfully obvious what's going on here. So I'm going to say the thread is finished. And then I'm going to say the timer should stop. And then I'm going to say thread delete later and timer delete later. Delete later could always come back and haunt us, but we're going to trust it in this specific case. Now I'm going to say thread equal new, and we're going to make this my class. And then let's go ahead and go timer and equal new. I swear I just heard a truck or something in the background. That's always the danger with recording these live sessions, is I cannot control what happens outside of these four walls. And I swear I hear like dogs barking and things like that. It's going to be interesting to see what really happens when I go to review these videos. And I'm going to say set object name. Let's call this child thread. One time I was recording a video while I'm just dredging out this code here. I was recording a video and I was doing laundry, and it actually picked up the washing machine, which is 2 floors under me down in the basement. It was like, what is that noise? So we're going to say timer, and we're going to set interval. Let's go ahead and set this as 1 second. Now comes the fun bit. We're going to say QObject, and we are going to connect our timer. Timeout, you guessed it. And we're going to connect that to the timeout function. Notice how this is a function, it's not a slot, but we're still able to connect it just because of the way QObject Connect works. Actually really handy. I love whoever put that in. Thank you so much. And I'm going to say timer. Go ahead and start that. And we're going to go thread start. Notice how we're not calling thread run, we're calling thread start. So under the hood, what happens is qthread start actually starts up, and then qthread internally calls run after it's done some voodoo magic with the operating system. Now because we are running on another thread, we can do other things in the background. So let's go ahead and save run. Let's see this thing in action. And sure enough, run on the child thread. And then finished on the child thread. So this thing did work. I mean, we have this whole object lifecycle here. So we have the my class created on this thread, which is our main thread. And then it's on the child thread and then on the child thread. So really, what is the big deal here? Everything worked. The problem is this. If we were to go in here and say something like public, and let's say int value, and we should have getters and setters and all that, but then in here modify that value, and at the same time we're doing that, say something like thread.value equal 55, how can you actually guarantee what the actual value is? You have two different threads doing two different things to the same variable. That is bad. That's a recipe for threading disaster, and that's why I do not recommend doing this. So while we're on the topic real quick here, what is the correct way of doing things? And we're going to really go over and just hammer this in incoming videos. So if we look at QThread, it inherits QObject, and it really is very simple. But let's flip over to QObject and just kind of scroll down here. Move to thread. That's right. Baked right into QObject is move to thread. So thread is meant to be off on its own, and you're supposed to move the QObject to the thread rather than actually inheriting it the way we've done. So while this can work, it is not the best idea, and it's easily breakable. So if you do this, please understand, no one will ever trust your code because it's so easy to break it. Okay, in the last video, we actually inherited QThread, and we had some other subtle issues. We're going to scrap all that. We're going to actually reuse a good chunk of that code, so there will be some copy and paste action, but I'm going to show you the correct way to work with QThread. So first things first, what are we doing? QObject is going to move to QThread, and this is actually very simple. Not the best idea, but it can be done. Notice I'm leaving this in here. Why? Isn't this the best way? Now, unfortunately, with Qt, there's always a better way. And why? You do not want to risk breaking the functionality of QThread. That's why we're going to move the object to the thread, and we're just going to simply move an object. So first things first, let's go ahead and add our myClass. And in case you're wondering, what is the best way? The suspense is killing me. Each video is going to show you a slightly better way. And then ultimately at the end, I'll show you what I think is what I consider to be the best way of working with it. All right, so we have our object here. Gonna copy and paste some includes. QObject, QThread, QDebug. We're gonna go ahead and make our deconstructor. And we are going to have a signal. Usually when somebody comes to me with some sort of threaded question, where they can't seem to get a value or communicate or something like that across threads, my answer is, have you heard of signals and slots? So public, we're going to say slots void run, just to keep it somewhat similar. All right, now I'm going to copy and paste some stuff in here. So in the constructor created on, and then whatever the current thread is, the deconstructor destroyed on whatever the thread is. And this is where I'm going to deviate just a little bit here. Let me grab some code, because this was in the previous example here. And I'm going to auto indent just because it's going to bug me if I don't. This is almost verbatim the exact same thing, except we're inheriting QObject instead of QThread. And down here, once we're done running, we want to tell some other object that we are finished. So we're just going to simply emit the finish signal. Signals and slots are deceptively simple. People tend to overthink them and think they need some sort of crazy handler or loopback or notification scheme. No, just use signals and slots. Very, very simple. Now we're going to flip into our main class here. And we have a whole boatload of includes that I put from the last. Do we actually need them? Let's go through here. Well, we've got two QDebugs. So QObject, QThread, QTimer, QDebug, QSharedPointer. Don't think we need that. myClass, which is this guy. Then we have a pointer to a thread, pointer to a timer, and the pointer to the class. Notice this is different. Last time it said myClass thread. Now we have an actual thread, a timer, and then the class. We're making these three distinctly different objects. Going to take the code from the last video. And in case you skipped it, super simple function, just void timeout. If there's no thread or no timer, we're going to drop out of here. And then we're going to say, if the thread is running, However, it is not finished, then the thread is running. Much simpler way of writing that. Just wanted to be very verbose, so anybody coming in here, it's painfully obvious what's going on. And then if it is not running and it is finished, then the thread is finished. We're going to stop the timer, delete the thread, delete the timer, and delete the class. So we're calling delete later, and we're trusting Qt to do our memory management. I don't do that very often, but we are trusting Qt to do that. So do not betray me, Qt. All right, so one thing we're going to do right off the bat here is we're going to say Qt thread, if I can type, current thread. I want to set the object name here. That way we know what is the main thread and what's not the main thread. And then I'm going to say new Qt thread. Now you may be saying, now wait a minute, if you're setting the parent, why do we need to do the delete later? You really don't need to, but in practice, when you're done with the object, you should get rid of it. So timer, and let's go ahead and go my class and I'm going to say null pointer on this. And I want to highlight that, no parent. Why? Because we're going to move that from one thread to another. And that's one of the little gotchas with the move to, is that you cannot create this on one thread and then move it to another thread if it has a parent. You get some sort of crazy cross-thread operation, and Qt gets really angry really fast. And I'm just going to say set object name child thread. Let's lowercase that t just so we're consistent here. Now I'm going to do a whole boatload of object connections, and to save time, we got some copy and paste going on. So let's go through these super quick. Qt object connect, we're connecting our timer to this timeout function here. We are connecting our thread started to the my class run. So when the thread starts, it's going to go into my class and call this guy right here using signals and slots. And let's make sure that's actually a slot here. Yep, public slot run. Now we're going to say QObject connect my class finished, that signal we're going to emit when we're done running, to the thread quit. So really what we're doing is we're saying when the thread starts, run the class. When the class finish the thread. Got a little bit of a loop going there. It's kind of cool the way that works. Signals and slots allow you to make some pretty interesting code and a little bit challenging to figure out if you're new to it. So now we're going to say my class move to thread. And we're just going to move it to our thread pointer. And we're going to say will fail if there's a parent. So that's the little gotcha right there. So if we try to say my class move to thread, but my class has a parent, remember we did no parent, you're going to get a failure right there. And let's go ahead and say timer set interval. Let's go ahead and set this to 1 second. And then let's go ahead and say timer start. And thread start. And then we can simply do other things in the background here. All right, so the code looks overly simplistic, but it's actually much stronger than the previous example where we inherited QThread. Let's run this, see it work. All right, so we have the class was created on the main thread. The class was run on the child thread. The thread is running. And then my class finished on the child thread. And the thread is finished. And everything just worked. And it worked beautifully. And if you watch the videos, we're using the Qt connection because we have a cross-thread operation. Now let's play around with this a little bit and see at what point we can break this. So let's actually get rid of that. Get rid of that. We're going to use auto connection. Save run. Let's see this thing work. So created on main thread, moved to child thread, or should say running on child thread, and finished on child thread. Thread is finished. Now if you had an older version of Qt, that was not the case. Auto connect is awesome these days. So if you run into problems with that, make sure you're using a Qt connection. General practice, because I'm very distrusting, I tend to force the Qt connection regardless. Now let's talk about this guy right here. If we take out this null pointer and just simply do this, give this class a parent. Well, let's go ahead and build this. Notice we get a good build. Save run. Cannot move objects with parent. That's exactly what you're going to see. But then this happens. So this is one of the little gotchas here. So our object cannot move to thread. The thread's running, the thread's finished because there was nothing for it to do. And then the class was destroyed on main thread. So it never actually moved to the thread. That's one of the little gotchas. So why is this better than inheriting QThread? It's very, very simple. When we run this thing, the entire object is moved over to this other thread. So my class is now on the child thread. And when it's finished on the child thread. So we have less chance of collision between threads. We're not going to have a cross-thread operation. And we have better encapsulation because this entire object now lives on that other thread. Can we go in here and still do something like my class dot value equals something? Yes, we can. Bad programming to do that, but you can still do that, and you will get, variable corruption and things of that nature, other things. And that's why we have other videos coming up where I show you what I think are slightly better ways of doing things. Just wanted to put a general note out there. This is much better. Move to is much, much better than actually inheriting QThread. Let's talk about the thread pool, and it's assumed that you've already worked with it, but this would also be a good primer in case you haven't or you haven't touched it in a while. So what is a thread pool? Well, it is a pool of objects, in this case a pool of threads. And object pools are something we're going to cover later on when we talk about classical design patterns. But think of it as you have a group, literally a list of threads, and you can reuse them as you need them. It's actually really, really cool. Reading into this, you can see that to use a thread pool, you have to subclass a QRunnable. So it's not pretty much straightforward. You don't just hand it a QObject, you actually hand it a QRunnable, which is not even a QObject. That gets super confusing. Let's take a look. I'm going to dive in here, and let's say Qt 5 design patterns, this is 6.3. Paste my notes in there. All right, so why even use a pool of objects or a thread pool? Well, threading is expensive in terms of memory usage. So let's say you want to make 1,000 threads. That will be very challenging for most machines. It just simply isn't the way things work under the hood. And you really don't need 1,000 threads is really what it boils down to. So let's take a real good look at this, and we're going to go class, new class. Don't zone out. We're going to do something a little bit different with the my class. All right, we're going to make this a QObject. Notice right off the bat, I said that the runnable is not a QObject, but I made a QObject. So what we're going to do here is we're going to include QObject, QThread, QRunnable, this little guy, QDebug, and QRandomGenerator. And right here, we're going to inherit QRunnable. So now we have the best of both worlds. We have a QRunnable which can run inside of a thread pool and a QObject which can use signals and slots. However, there's a couple small gotchas that we're going to discover later on. Right click, insert virtual functions. We want the QRunnable run. Notice the naming convention run, very similar to the last few videos we've done. I love the fact that they keep redoing that little pattern over and over again. It makes it super simple to wrap your head around. And then I'm going to, just through the magic of copy and paste, we're going to make some signals. Started, finished, and project. Yeah, progress. Got a little tongue-tied there. Let's go ahead and make a deconstructor. The struggle is real in this video. Can't talk, can't type. All right, so let's go ahead and refactor. Let's add this. So just to recap, constructor, deconstructor, and run, which will be the QRunnable interface. This is what actually gets run in another thread. Going to copy and paste here. So in the constructor, created on whatever the current thread is, deconstructor destroyed on whatever the current thread is, and then in run, run on whatever the current thread is. Now we're going to go ahead and we're going to emit the started. And because we emitted started, let's go ahead and emit finished. Notice something right off the bat. The class already exists, but we're pretty much expecting its full life cycle of functionality, I should say, in the run function, because this is what happens on the thread. Everything outside of run, or that is not called within run, is outside of the thread pool. All right, so do thread stuff here, and I'm just going to say for int I equals 0, I is less than 10, nothing super special, just going to do some random stuff. And I'm actually just going to save a snippet of time here. All we're really doing is saying for I equals 0 to 10, we're going to make a random number between 0 and 200, and then we're going to put this current thread to sleep. Now this is the pooled thread, meaning this is a thread inside of the thread pool. And unfortunately, even though we can grab the current thread that we're on, we don't have a whole lot of control over it, because remember, this is managed by the thread pool. And then we're just going to say QInfo, this object, progress is I, whatever the value of I is, on whatever the thread is. Very, very simple at this point. Now what I want to do, you may have guessed, is make the actual pool. So I'm going to say class, and let's call this my class manager. So we're going to have QObject, QThreadPool, QRunnable, and myClass. And this is just going to inherit QObject. From here, we're going to add in a run function, not to be confused with the actual threading run. We could name that something else if it's a bit confusing. And then I'm going to go over here and just grab these guys. And we're just going to make some slots that line up. Going to implement all of these. Whoa, what did I click there? Bang, that's not what I wanted. All right, now we're almost done. We just have to implement this and then run it. For our run, we are going to say, I'm going to actually say QInfo, and I want to say max threads, and I want to say Q thread pool global instance, and I want the max thread count. That way we see right off the bat when we go to run this how many threads we are actually maxed at in the pool. Remember, a pool is a list, an internal list of reusable objects. All right, so you're going to see real quick that we have a very small amount of max threads. Typically, this is the same amount as the processor that you have in here. So I'm going to say for int I equals 0, I is less than, and let's make some large number larger than what we probably have in our max. And then I'm going to say my class and I'm going to say null pointer for the parent. Because we're using threads, we can have no parent. Otherwise, we're going to have that, cannot move two thread kind of issue that we had in the last video. Now I'm going to say my class, and I'm going to say set auto delete to true. This is going to come back and hurt us later. And you may be scratching your head going, now wait a minute, we're trusting Qt. Alright, this will cause issues in this video, and there's a reason for that. We're going to use these slots, so we're using the QObject signals and slots, and when we consume these or use these, we may not have the my class object if we trust auto delete. So for example, finished, let's go here. Emit finished. When this is emitted, Qt's just going to send it out into the signal slot manager under the hood, and then this will get called. And when this gets called, this may already have been deleted. And we're going to see if we can demonstrate that. Sometimes it works, sometimes it doesn't. But going to grab some stuff off the screen real quick here. I absolutely hate typing connection code. That's why we made that auto connection class in a previous video. But real simple, we're just going to connect my class to the my class manager. So my class started to this started, my class progress to this progress, and finish to finish. So started, finish, progress. Not super hard to wrap your head around. I just really hate typing connection code. So my class, and I'm going to say set object name. And yes, someone out there is going to say, wait a minute, Qt has built-in auto connection and you have to just follow their naming convention. I get that. I just don't trust it, and it doesn't always work in my humble experience. So I'd rather have something that I trust and that I can rely on. So, all right, so all we're doing is we're creating a class, no parent, setting auto delete to true. This may come back and hurt us later on. Setting the object name to my class, and then a string representation of whatever I is, connecting our signals and slots, and you guessed it, now we have to actually put this into the object pool. So we're going to say QThreadPool, global instance, start. So same kind of naming convention, start is going to call run. So what we're going to do is we're going to say the global instance, which is baked right into every Qt application, is going to start our runnable, in this case, my class. And that fires off immediately. All right, so what happens under the hood? I'm going to just take this, do a little copy and paste action. All right, my class, QObject cast, we're just going to grab the sender and say, can we get an instance of my class? If not, return. And this is where I'm going to do some little extra copy and paste. Notice this is on the main thread. Very, very important. This is on the main thread. So because we're using the Qt connection, and if we even delete that and use the auto connection, it's still going to be queued. This guy, my class, is going to run in the pooled thread, and the slots run on the main thread. Very important you understand that distinction, that just because we're connected to signals and slots does not mean that these slots are threaded. These are not. So if we block these in any way, shape, or form, we are blocking the main thread. And to kind of prove that, we can say QThread current thread. And this is where we're going to start seeing some things get a little bit weird. I'm just going to take this little snippet and we're just going to use this over and over again. So started slot, finish slot, and then let's go ahead and grab this again and do progress. If I can spell progress. Sometimes I need to slow down a little bit here. And then we're going to say, I want to get the value here too. Little detour real quick. You might be wondering why when we do signals and slots, why we don't do something like this, just simply return a value. And this is exactly why threading. If we say return a value, really what happens under the hood is Qt takes this, turns this into a byte array, or actually a string representation of it, and then attaches some extra data in the background of whatever this value is. In this case, it'd be like 12 or 123 or something like that. So it can't really do that in the sense of what you're thinking with a function that returns some type of value. So if you want to return a value, always do it as a parameter of the signal. Short detour, sorry about that. All right, let's just take a quick look at this, make sure everything's kind of how we expect it. All right. I personally fully expect this to crash. Why? Set auto delete is true. And in my class, we are emitting a signal. And this is almost why in almost all of the Qt documentation, you do not see them combining QObject and QRunnable, because you run into this sort of issue here. And what's going to happen is the my class is going to emit finished. Under the hood, finished is going to be called the slot, and we may run into issues. Let's check this out. Let's go into main, and let's actually add in a Q thread. And let's include the my class manager. And in case you're wondering why I want QThread, I'm just going to say QThread current thread set object name main thread, so we can really easily see what's going on. And then I want the my class manager. Let's call this manager. And I'm going to say manager run. We could have called that manager start or whatever we wanted to do. Doesn't really matter. Save and run, and let's see if we can make this thing go boom. Oh, sure enough, it was running just fine, and then mallet consolidate invalid chunk size. What? What in the world does this mean? So memory allocate consolidate invalid chunk size, but we haven't done any memory allocation, or have we? So scrolling up, max threads 8. And we have a whole lot more than 8 going on here. We have 25 in total. And as we go, we see how, let's look for the highest number so far we have here. All right, so I'm looking class 5, 6, 7. I think the highest is probably going to be 8, but let's find out. All right, so there is my class 8, and then 0, 8. Just looking for something higher. Oh, there's a 9. So we did get a little bit higher. 11. And then boom, blew up. Why did this blow up? Well, again, signals and slots have betrayed us. So let's go back in here. Let's set this to false and say true will cause issues in this video. So now we're going to say my class set auto delete false. Now when we do this, this pointer is going to live out in memory, meaning now we have to manage that memory. We have to do something with this. So we are now taking full ownership of this pointer, and we need to figure out what we want to do with it. So let's look at our run function. Everything in here or called from here runs on this thread, except for, you guessed it, signals and slots. So we have cross-thread operations. So by the time we get here, this may not exist anymore if it was set to true. So something like this could be happening. under the hood. Delete this, but then it's emitting finished, and then when we go in here, we are getting it, but it lines up the sun, moon, and stars, and everything else lines up, and maybe we get this and it passes through here, but then it's deleted, and that makes us go boom. And that may not even be the case. It could be now it's confused about which thread this thing actually lives on. Oh, that is just frustrating. So let's get rid of this. Leave our run the way it was. We have set auto delete to false, so now we have to take care of this. We know we're done with this when we get to this point. And we're going to schedule that for deletion through the Qt's version of garbage collection, the delete later. We could call delete and actually just do it now, but I'm going to be super nice with Qt and say, Qt, you tell me when you're done with it, because I'm done with it. And that allows Qt to do anything else it needs to do under the hood. Save and run. See if this thing runs or if it crashes, and it should run all the way through. And sure enough, everything ran. It is now finished. So looking at this, we have a lot going on, and I'm just going to scale that out here, scroll all the way up. So we have 8 max threads in our pool, and each of these threads is getting reused. So you can see we have a whole bunch of creations on the main thread, and then started on the main thread, and then boom, everything's running in the pooled threads. And you can see the different memory addresses of those pooled threads. And then we just have a whole lot of noise, and then we start seeing where things are finishing. They're destroyed. Now notice how it's destroyed on the main thread. Where's that coming from? Let's look at the destroyed word. Close that. So finished, nope. Started, nope. Progress, nope. The only time we actually call destroyed is, you guessed it, destroyed on. Why is this? So let's look at what's going on under the hood. So we're creating this class on the main thread. And we're actually destroying this class on the main thread. If you ever get confused, just remember, when you're working with a runnable, everything in run happens in the thread. And I'm actually put it right here. What happens in the thread stays in the thread. Kind of like what happens in Vegas stays in Vegas. Think of it in that terms. What happens in the thread stays in the thread. So once you wrap your head around those little gotchas, it's pretty easy to use this, and you can use signals and slots, and everything just works in this beautiful, elegant little dance, and you have a pooled collection of threads, I should say a pooled list of threads that you can reuse over and over again, and in terms of memory costs, it's very, very small. This threading stuff is hard and it gets confusing. So wouldn't it be great if we could just say, hey, you know what, Qt, take this function, go make it multi-threaded, and give me the result back. I don't want to mess with any of this. That's exactly what Qt Concurrent does. So Qt Concurrent provides high-level APIs and makes it possible, blah, 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 to avoid any of the low-level primitives, which is where all of the mistakes happen. It lets you just focus on getting the job done. Now, I'm just going to say it. I love Qt. I absolutely love their technologies. However, every time they make something simpler, they make it infinitely harder to understand, and their documentation, not super helpful. So what we're going to be focusing on is the Qt Concurrent run, and in all fairness, this is a highly complex topic, and this is not for the faint of heart. We're going to do our best to make it super simple. Their documentation is probably about as good as it's ever going to get, but if you're just like a little newbie coming in here, you can't really figure out what the heck you're supposed to do or even where you're supposed to start, and you're going to be here for a while. So the goal of this video is to say, hey, let's take one function, make it super simple, return a value, but make the whole thing threaded. So Qt Concurrent, high-level threading, threads are complicated. We're going to do a folder counter. First thing we need to do is we need to include in our project the concurrent library. If we forget to do that, we're going to have a bad time because it's not going to know what we're trying to do. That's usually the first step where people screw up, is they just don't include that. Now I'm going to, at the risk of making things super confusing, make a class. And we're going to call this file scanner. This is going to be a Q object. All right, I'm just going to put some includes in there. Q object, Q debug, Q file info, Q dir, Qt concurrent. Notice it's Qt concurrent. We're calling a whole library, not just a class. And Q future. So what are these little guys? So Qt concurrent is the library, or actually the framework for concurrency inside of Qt. And the Q future, this is literally a future value that we're going to get out of the concurrent framework. So whenever you see future, think of like the movie Back to the Future, where Marty goes off and he does some things, but he doesn't worry about it because that's a problem for future Marty. So this is future us. We're going to get some sort of future value, hence the name future, from concurrent. So this would be our DeLorean, and this would be what we're going to get out of that. Whew, super confusing. And we haven't even started yet. I'm going to make a function called scan. And right off the bat, you're going, no, wait a minute. We said we were going to get some sort of value out of this. Well, we can through the magic of signals and slots. So we're going to say scan. I'm going to copy that. I'm going to say signals. I want void updated int count. And then for private, I'm going to paste that scan back in there, but I'm going to say perform scan. Now, signals and slots, you typically would not have some sort of return value. Well, we're not working with slots, we're working with a function. We want to take this function and make it threaded. And then we're going to say qint64 mcount. Realistically, we should also make this a qint64, but I'm going to just put it as an int for now. All right, so we have got constructor scan and perform scan. Now I'm going to copy this. I've got some notes off the screen here, so there we go. And we're going to do something threaded, and we're going to do something that could take a long time. Q future. So instantly, as soon as you see the word future, you should know that we're doing some sort of threaded operation. We're going to say Qt concurrent, and we want to call run. And whoa, there is a lot of options for us to choose from. So really simply, we're going to say take the current object, call a function using a parameter, and this function, perform scan, is going to return some value, but we're going to do it in a threaded manner using Qt concurrent run. So it's going to be a future value of a type int. That gets really confusing. To break it down, Q future says in the future we want an integer. Our future is going to be Qt go do something, make this thing awesome, this object, this function with this parameter, which is actually this guy right here. Now I'm going to grab this off the screen, paste it in. Simply put, the main thread is not blocked. We can do other things. We can do anything we wanted because Qt is off in the background making this awesome for us. However, when we say result equals future result, right here we'll actually, if the result's not ready yet, we'll block until it's ready. So we're going to get the result back from the concurrent thread. Seems confusing, but basically get a value in the future using Qt concurrent run, call an object's function using a parameter, in our case this guy, do some stuff, and then when we're ready, we want to get that result. Whew, man, that gets really confusing, but it's actually really easy once you do it a few times. And yes, there's a reason why we covered thread pools already, because you guessed it, in the background this runs on a thread pool. So what's really happening is Qt concurrent has the global thread pool. It's making a runnable for us. It's putting this on the runnable, running it, and then returning the value. It's actually really, really awesome. There's a lot more to it. It gets really complex under the hood. Hats off to the people who developed this. We'll say value 0. Honestly, I've peeked at the code. I don't think I could have written something like that. It blew my mind when I looked at it. Some people out there, especially you C++ masters, are going to go, oh, it's super, super simple. And I'm just like, nope, it's not. So if the... Got a little ahead of myself, didn't I? So we're going to... See, I get to talking, and then I can't talk and type at the same time. So qdir path, then I'm going to just say, if not exists, then I'm going to simply return a -1 and say, nah, if it doesn't exist, I don't want to worry about it. And what we can actually do, qinfo performing scan on qthread current thread, and you'll see that this is a pooled thread. We may comment that out because it gets super, super chatty. qfile_info. This is where I'm probably going to goof up. I am not good at this part. So we're going to say dir entry info list, and I want to say, I can never remember this. I think it's qdir. I don't want to get the directory. I think it's no dot and dot. There it is. And we want to make sure that we are counting folders. So and that's dirs, not dir. Uh-oh, did I screw something up here? I told you I would. So qfile_info list. Ah, it's not a qfile_info. It's a qfile_info list. There it is. qfile_info list equals dir entry info list, and we want to avoid the dot and dot dot. If you're wondering what that is, when you're in a directory, the first item is a dot, the second item is a dot dot, which means current and parent, and we don't want to like double scan the current and scan upwards. So we're going to ignore those, and then we want to do only folders. Whew, that part just messes with my head sometimes. And then we're going to say the value equal the list length, because we're just getting the length of that qfile_info list. And then for each, super simple code, qfile_info in our list. And then we want to say the value. We're just going to recursively call this function, and we want to say item file path. I called that info, not item. There we go. That should work. So basically, we're just recursively calling this over and over again. If you've ever done this on the main thread or the GUI thread, you know this could take a long time. It may make your application freeze, and some operating systems like Windows, I'm thinking of specifically, will say, hey, this application's not responding. Do you want to wait or close it or whatever? That's typically what happens there, is when you recursively call a function that's going to take a long time. Whew. All right, so that is super simple, but it's also very cool. So we're saying, hey, this line makes the magic happen. This line gets the result back. We can do other things while we're waiting. And this simple little function is now threaded, running on a thread pool. Let's prove that. Let's see if we can actually break this thing. I'm going to do some copy and pasting. QDebug, QFileInfo, QTextStream, QThread, and File Scanner, this guy. I'm going to, just because it's very simple code, QString, get path. Really all this is going to do is say open the standard input and then say give me a path, return the value. Grab some more code. All right. And then QThread current thread, set object name main thread so we can see the differences in the threads. And then we're just simply giving this path. There's a much more elegant way of doing that. I just put it in there. I try to make this code newbie friendly so if somebody skips a few classes, they're not completely lost trying to figure out what all this stuff does. We're going to make our file scanner, and last but not least, we're going to say fs.scan, and we're going to scan that path. Let's give it a good build, make sure we didn't goof anything up. All right, so what's going to happen? Program's going to run. It's going to say give us a path. If we give it garbage, it's going to keep saying give us a path over and over. Once it has a valid path, it's going to echo that path out. I should say info that path out. Then we're going to make a file scanner scan, and it's going to say, hey, you know what? This could take a very long time, so I want to do this concurrently. Qt concurrent run is going to take this object with this function and a parameter, a path, and it's going to take this whole thing and shove it off into the thread pool. And when it's done, then we will have a future result. We can do other things, and at our convenience, when we're ready, we can say future result, and this will block if it's not ready. If it's ready, it's just going to hand it back immediately. Save run. Enter a path. Let's enter some trash. Yep, sure works. Let's bring up an actual folder here. So this is my video recording folder. This is actually the video recording right now. These are the previous videos. I've got like Blender, CPP, some GitHub. I mean, these are all of the videos that I've recorded for Udemy. I mean, this is a pretty sizable directory here. So I'm just going to right click, copy that path, and let's go here, paste. There we go. See how that is super, super cool. So let's scroll up. All right, scan on QThread, main thread, bang. Main thread is free to do other things, and then you see, sure enough, performing on a pooled thread. And because this is going so fast and we aren't using other things, it's just reusing that same thread over and over and over again. But that's incredibly cool, and there's our end result. Now, you may have noticed right off the bat here, we have this signal. Because we're using a command line application, this really isn't super helpful for us. It's not really doing a whole lot, right? But what we could do right here, if we have a GUI application, is we can emit this. And then this is super chatty, so I'm going to just comment that out. Save and run that again. Let's go back and get this path. Much faster, at least on the screen. It was about the same speed. But you can see just how cool that is. We can take an entire function, throw it out on the QThread pool, let Qt handle all the details for us, and we're just worried about that end result. Let's take a look at multi-threading with a GUI. And for this video, we're going to use widgets. Next video, we're going to use QML. So we're going to develop the classes in this video, use them, test them, and then the next video is going to be QML. What's the problem here? Well, when you get into threading and you have a GUI, you have what are called cross-thread operations. So you see why I have the simple interface path, some file path, along with a total here. And let me just kill this, rerun it. This is what it looks like idle. And if I just hit count, bang, one folder, because, well, we're on our current folder here. We're going to make the path shorter and shorter, and you'll see that it takes longer and longer. So there's 31, 63, and then Oh yes, takes a while. You notice how about every 1 second it was updating. So what I'm talking about here is we want to update the GUI, but in a structured and reliable manner that's not going to flood the user with information, but still gives periodic updates. And this is really a good use case of why you would deviate from like Qt concurrent. All right, so let's get that out of there. And we're going to actually close this whole thing. And we're going to make a new, and we want a widgets application. And I will probably, almost definitely, screw some things up. And we'll say 6-5, next, next, and instead of Q window, we want a Q dialog. Next, next, next. All right, super simple, super easy. We just got this blank little dialog here. And we're going to build that out later. First thing we're going to do is we're going to work on our classes here. So it's going to copy in some notes. And we can reuse a lot of the code from the previous videos. There's no sense in retyping everything if we don't have to. And then get rid of that via threads and update the GUI. All right, so let's check this out. Don't even know if we're going to use the move to, so I'm going to get rid of that as well. What are we going to do? We're going to modify that file scanner class and show in widgets. And we're going to show how to update the GUI, in this case widgets, from a thread. The goal here is not locking the main thread. We're going to count the folders via threads and update the GUI. Pretty self-explanatory, but it gets pretty complex pretty fast. So what I want to do is I want to make a Q runnable and run that on a thread pool. So I'm going to say new class. Let's call this scanner. Make this a Q object because I want signals and slots. And then I'm going to grab some includes off the screen here for my notes. Q object, Q runnable, Q debug, Q thread, Q file info, Q file info list, and Q dir. So pretty much the same structure. It's just now we're doing threads instead of Qt concurrent. And we are also going to inherit Q runnable. Q runnable run. I'm going to move this up so we can try to get that all on the same screen there. There we go. I want some signals, so I'm going to say signals, started, updated, finished. And then let's go down to public. I actually just want to get rid of this. It's kind of annoying how it does that sometimes. All right, so here we can just say QString path. And you know what? I always fight the IDE. Let's do it the IDE way. Private, say QString and path, and then we can just say right click, getters and setters, makes it super simple. And then let's go ahead and do qint64 mcount. Now, if you've watched the previous videos, you notice how I did a qint64, but then the function was an int, and that would basically be a problem if we got into larger counts and we exceeded the size of an int. We're trusting that it's going to cast it for us, and it's probably not going to actually do that. So I actually don't think in the previous example we even used mcount. I think we just incremented a value here. So I was trying to show, and probably not well, how to build up the example over time. So perform scan, we're using pretty much the same pattern. And let's just take that. So now we have our default values. Our run should be super, super simple. We should be on the thread pool, just in case we need to reset that. I'm going to perform the scan. We should do some sort of logic, like make sure the path actually exists and things like that. And then when we're done, we're going to emit finished. and I want to emit the actual count. So we are going to use the count here. And this is where we would have some sort of issue where, let's go back into our scanner here. Like we should say qint64 here and here and here, but I'm going to actually, just for the sake of argument, change that to an int so everything lines up. That would have been an issue in our previous one. All right, so now that we've got this, this is running in the thread pool. So anything we call in here is also running on the thread pool, except for, you guessed it, signals and slots. So count 0, perform scan, and this is just going to be a recursive function. And I am actually just going to copy and paste that in. There's no sense in wasting a bunch of time. mcount increment, and we're going to emit updated. qdir path, if it doesn't exist, just return, and then we're going to get a qFileInfo list of directories not including dot and dot dot, and then we're just going to recursively call this over and over and over again. Once it's done doing its recursive call, it'll jump to here and we will emit the finished. Oof. All right, so did we miss one? Yes, we did. Started, I do believe we missed started. Let's go ahead and jump right here. All right, so we are starting, doing something, and then emitting updates as we get them. Now, if we have a lot of folders, we're going to be emitting this update quite a bit. And if we're hooking directly into the user interface, that user interface is going to get what's called jammed up, or we're just going to flood it with signals, and it's going to start slowing way down. So we don't want to do that. What we're going to do is set that on a timer. And let's give that a build, just make sure we didn't screw anything up here. So what we're going to do next is make a class called FileScanner. There's quite literally thousands of ways of doing what I'm showing you. I'm just kind of whipping through as fast as possible, probably making horrendous mistakes along the way. QObject, QDebug, QFileInfo, QDir, QThread, QThreadPool shows you what we're going to be doing. QTimer, again, we don't want to jam up that interface, and we're going to use that scanner. This is going to stay a QObject, and we are going to, and I'm going to, for the sake of time, plop those in there. So we're going to have a scan function. Let's go ahead and implement that. Some signals, scan started, scan updated, scan finished. Notice that kind of mimics what we have in our scanner, started, updated, finished. And then we've got some slots, started, updated. And if you're thinking we're going to connect those, you're absolutely right. Those are going to get connected to our scanner, which we just created. And then timeout is going to be for our timer. So now we've got scan, path, started, updated, finished, and then our timeout. We've got our timer and our count. Whew. Seems really, really confusing, but we're going to try and jam through this as fast as possible here. So there will be some copy and paste action. So we're going to use a timer to slow down the update process because we are going to get a flood of updates from the scanner class here. And we don't really want to really just jam up that interface with updates. So we're going to set that timer to every half a second. And then we're going to connect the timer's timeout to our class FileScanner timeout, this guy down here. So let's just go down here. We're going to emit, not in caps, emit scan updated with the count. And then we're going to just work our way up here. So when we're finished, we're going to say mtimer stop, and then we're going to emit finished. I should say scan finished with the value. Updated, we are going to just say mcount equal value. And then started, we're going to just emit scan started. Not super complex. Scan is really what does all the heavy lifting here. So I'm going to say mcount equals 0. Again, there's millions of ways you could do this. Timer start. And then I'm going to say scanner. I'm going to make this a null pointer because we are going to shove this off onto another thread. We're going to say scanner set auto delete true, just because I don't want to mess around with memory management. If we start getting errors, I may have to revisit that. And then scanner dot set path. In case you're wondering if there's like some method to my madness, I do have some notes off to the screen, but I try to do this in real time. And what I mean by that is my notes off the screen are very, very rudimentary. I just have some things of what I want to do. And that's why there's some where they don't line up and things of that nature. All right, so then we're just going to do some connections here. So we're going to connect our scanner, started, update, and finish to this class's started, update, and finish using Qt connection. We can easily use auto, and it should use Qt connection in the background, but I'm very untrusting, so I want to make sure that I do that. From there, we're just going to say Q thread pool global instance start that scanner. And we're pretty much done. I mean, it's not super hard. So really all we're doing is we're creating a runnable that's going to do some stuff. And then we're taking that runnable and putting it into the QThreadPool global instance. Very, very similar to what Qt Concurrent is doing for us in the background. But I want full and total control over that entire process. All right, now what we need to do here is we need to jump in here and build out our interface. So we are going to need a button for sure. And let's call this button count. And we're going to need some sort of line edit because this is going to be our path. And of course, we're going to need, I'm just trying to think this through here. Let's call this txt path. And then we need a label. Let's call this LBL status. And we're just going to say status idle. And we can scale that out if we need to. And I'm going to grab these two, put them side by side, make the master this, and our beautiful little interface is pretty much done. All right, so now I just want to right click this, go to slot, and we want our QAbstract button clicked, and we are good to go. So now we are in our dialog code. I just want to jump in here, make sure I got everything that I need, and of course I do not. So I'm going to grab some notes. QDir, QThread, QFileScanner. Not sure if we're going to use all those, but let's just see. I want to jump into our file scanner here, get our signals, go back to our dialog. Let's turn those into private slots. They'll happily live alongside that button on clicked. And this is the Qt naming convention. I personally don't like the whole on underscore or something something clicked. All right, so scan started, scan updated, scan finished, and then we're going to make our file scanner. Let's implement these real quick. All right, now I'm going to do some copy paste just to save some time here. All right, so we're just simply going to make sure this actually works here. May have to build, unless I got the name wrong. I do. And we're going to say qdir current path. There we go. All right, so we're just simply connecting our file scanner, scan started, scan updated, scan finished to this dialog, scan started, scan updated, scan finished. That's why I didn't want to waste a lot of time typing all that out. Now, on our clicked, this is where we're going to say UI, the button, set enable, because we don't want to scan while we're scanning, to false. And then I'm going to say file scanner, scan, and then whatever the UI.txt path text is. And this, I'm going to just say it, is not what you would call a production ready sort of example. I'm just showing you like the rudimentary bare bones of what's going on here. So I want to make sure that that button stays disabled. And then scan finished. Let's jump down here, just because I had that on the clipboard. And then I'm going to, on our scan updated, we're going to say UI, what do we call that? LBL status, set text, counting, qstring, number, and then whatever that value is. Again, billions and billions of different ways that you could have done this. I'm just doing it this way just to show it can be done. And then once we have scan finished, I'm going to say total. And we're done. It's really that simple. Save, let's give this a build. Assuming we didn't goof anything up, it is that simple. Let's go ahead and run. Status idle, we're going to click, and bang, one folder. So let's test this out again. 32 and 64 and a lot. So what's really going on under the hood here? Let's break this whole interface down and just have a realistic conversation. When we click this button, we are jumping over to the file scanner scan, and we're making a new scanner, telling it to auto delete, setting the path, setting our connections, and then we're saying thread pool, go do this. And then because we have these signals and slots set up, we get instant, I shouldn't say instant because it is queued, but we get near instant feedback through the signal and slot mechanism of what's going on under the hood with the scanner, with the started, updated, and finished. Again, there's a million different ways you can do this, but if you're going to update a graphical interface and you're going to have thousands and thousands, like, so for example, if we just do this, and actually, why not? It might actually crash because we may not have access to everything. You see that's just going and going, and it was actually fairly snappy, but if that were to run for a long time and you sent 57,398 signals to this interface might stop responding. So that's when I add a timer and I say, okay, periodically update, and that's where this timeout comes in. So let's switch here. Here's our timer. So instead of every single one, we're saying, okay, go ahead and do it on a timeout fashion, and that's where we're emitting it every half a second here. And we could increase or decrease that. But just know that every time that interface has to stop and update, while this example is fairly fast, if we were to do that 57,000 times, this interface has to update and paint in the background, and that takes real time, and that has a real cost performance associated with it. So the big takeaway from this video is, yes, you can do cross-thread and cross-platform. With signals and slots, it makes life super simple, but the minute you add a graphical interface to it, you have to start thinking about what you're doing to the main thread. And if you're going to tell that main thread to update an interface 57,000 times, this interface may stop responding. So to combat that, you do it in a timed manner using a timer in the background. let's take the same file scanner class that we made in the last video and used with widgets and use it with QML instead. I want to show you specifically in this video how you can reuse the code. There's a couple minor little tweaks we need to do to get it to work with QML, but it's pretty straightforward. So I'm going to say new, and I'm going to go to application Qt Quick application empty. This is going to be Qt 5 design patterns 6.6, should say 6-6. And we have just a very basic empty QML application. So I'm going to go to our folders. This is the previous video. This is our current one. I'm going to go into the previous one. I'm going to grab the file scanner and the scanner class here, and then we're just going to paste these in. So we're literally reusing the same class. I'm going to go in here. We're going to add existing files, and I want to add the file scanner and the scanner. Give that just a second to update. There we go. Now, in case you skipped the last video, what's really going on, quick recap here. We're using QThreadPool under the hood, so we have a scanner, which is a QRunnable, and a QObject, which is going to perform some scan. And that scan is very, very simple, very rudimentary. It's just going out and saying, hey, scan, no dot and dot, only directories, and perform that scan, and then do some sort of updates in the background here. And the file scanner, whew, there's a lot of talking. The file scanner just creates a scanner with a null pointer, can't have a parent, sets auto delete to true, sets the path, signals and slots connected up using Qt connection because we're doing cross-threading, and then puts it out on the QThreadPool. From there, signals and slots lets us know what's going on, and we can update the GUI. And the thing I really wanted to highlight in the last video is when I scanned a folder, there was like 57,000 subfolders in there. Doing that, updating the GUI 57,000 times would actually make the GUI non-responsive, and I actually put right here, updating the GUI is slow and we want the application to remain responsive. So, in short, we use a timer every half a second to update the GUI. And really all this timer is doing is saying timeout, file scanner timeout. We're just emitting a signal saying scan updated. So the files, or I should say the scanner, may be updating this file scanner 57,000 times, but the file scanner is going to use a timer to update the GUI every half a second, rather than completely flooding the interface with updates. And then you can tweak it like every second or every 2 seconds or whatever you wanted. Whew. All right, lots of explaining. We have a problem right up front. The first problem we have is that QML needs this class. So we need to go into our main here, and let's go ahead and include the file scanner. Now we need to do what's called a register type. And if you've worked with QML before, you know exactly what I'm doing. We need to tell QML that, hey, this class exists. Because it's a QObject, we can use it inside of QML, but we have to register the type. So we're going to say QML register type. And I want to register this as a file scanner. And now I want to, we have to give it a UID. So I'm going to say com.company. Give it a version, a major, and a minor, and give it a name that we will work with. In this case, very simple, file scanner. Now we can create as many instances in QML as we need. A lot of people will ask, well, why do you use register type? Why don't you just set context property? Because I don't want to actually create an instance of this until I need it. And I may need more than one instance, so I'm going to register the type and work with it in QML as I need it. So QML register type makes this available to QML. Let's give it a good build, make sure everything is the way it is and everything's happy. Good. Let's go ahead and build out our interface here. And the designer, I'm just going to level with you. The designer and I are not friends. We try to be, but we're not often fighting with each other. So you may see me fight with this thing. Qt Quick Controls. There we go. And we may get that dreaded M16 invalid property error again, which we've talked about in previous videos. And if we do, that's a bug in the editor, not really in our code. So to zoom in and out, it's just Control, middle mouse button. I'm just going to zoom out a bit. There we go. Now I'm going to say I want a column. Going to drag and drop that down here. Bang. Now inside this column, I want to actually scale this out a bit. Inside the column, I want to put a label. See, this thing. I hate it when it does that. It always kind of goofs me up like that. So now suddenly it can't find labels, and then magically the labels are back in there. All right. Minor bug. There we go. So we've got our label, and let's say path. Might be super small, so we can zoom in if we need to. It says path. Now from here, we're just going to grab a row. Come on now. Why have you betrayed me? Why? Why? Why do you always betray me like this? See what I mean by this? Editor and I are not always friends. It's this little filter area that often does it to me. So let's see if I can get it to update again. No, we're just going to flip back. And magically they're back. All right, so anyway, sorry about that. We're going to drop the row in there. And I've had people go, am I losing my mind? Does this thing just magically do what it thinks it wants done? Yes, it does. It drives me insane too. So let's go ahead and find a text field. And we're going to drag that in there. And let's go find a button. Drag that in there. And let's go ahead and put some spacing in here. I want, not too drastic, 10. Let's go to our column. Let's do some spacing there. And I want to put one more in here. Let's put it right there so it drops at the very bottom. And let's set the height to, say, 200. Actually, why not? 100. Let's go 75. There's a better way of doing it. You can actually do a property binding and say this height should be the column height, or actually over to the button and all that. I just like doing it as simple as humanly possible. I don't want to really get detracted by QML and all of its little complexities. Although I gotta say, coming from widgets to QML, I absolutely love QML. Maybe that's a bit too much. Let's go 15. There we go. And we're going to say status idle. I want to grab this whole column and let's just move this thing. Very, very simple. So let's go ahead and call this scan. So we have a field. Let's just zoom in. We have a label with a text field, a button, and then another label. Let's call this LBL status, just because I like being fancy. And let's call this txt path. I'm actually trying to mimic a little bit the widgets application we did. Let's call that btn scan. Save this, flip over to edit, make sure we don't have any little gremlins popping up. Run this, make sure the interface looks as we expect it to. So we have a problem. How do we get that starting little path out of the file scanner? QML has no concept of I/O or a QIO device, so we have to work with this Q file, or I should this file scanner, which is a Q object. So doing this, we can actually add in a property. This is what I meant earlier in another video where I said Qt almost forces you to work with QProperty when you're in QML. So we're going to say QProperty. This is going to be a QString. Let's call this path. And I don't want a write or a notify, so because we have a read, now we have a function we have to add in here called path. Different ways you could do that, but we're going to do it the easiest route humanly possible. Right click, add that in there. Now all we're going to do is just simply return qdir current path. Let's go ahead and give this a good build, make sure we didn't goof anything up. Then we're going to go back to our QML file in editor mode, and we want to use that file scanner. This is where some complexities come in. So I'm just going to grab this, our UID, and I'm going to import our file scanner with our major version, minor version. And should note in Qt 6, it's rumored, I haven't confirmed, that versions are going away. So you should be able to do something like this. But because we're not in Qt 6, we're in Qt 5, we need that actual version. Give it a build, nothing blows up. All right, now, first things first, we want to be able to get that path out of the file scanner, that QProperty we just put in. So I'm going to say component on completed, and I'm going to say txt path text equals scanner dot path, and this isn't going to make much sense yet. So what we need to do now is make the scanner. So I'm going to say file scanner, and then ID. Let's call this scanner. Notice how it automatically highlights that so it knows what we're trying to do. So when this window loads, the component on complete, we're going to say txt path text equals the file scanner path, which if we jump back is just this QProperty. Seems really confusing, and I don't like the way Qt did that. I understand why they did it that way, but like I said, they really kind of force you into working with QProperties, and sometimes it's not fun. All right, anyways, from here we can hook into our signals. So I'm going to say on scan started. I'm going to say button scan enabled equal false, and then I'm going to say LBL status, and I want to say text starting, and then we can just grab this because we're going to use it quite a bit, and then on scan updated, scanning, and value. And if you're wondering how I magically knew what to do, it's not very intuitive when you look at this. You have to look at your actual signal. Scan updated, there's a value here. So it's actually pumping that name. Remember what I said about signals and slots? We'll convert this into a byte array, and it'll be a string representation like that. So then it's just parsing it under the hood, and that's how it knows there's a value there. You could also just go like this, go bang. And if you're wondering how I said bang, it's control space on the keyboard brings that up. And then you can see everything that's available to us and kind of scroll down, 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 down. And it may actually not even be in there. Nope, it's not in there. There it is. So if I hit V, there's value, but it doesn't really kind of indicate. And this is something I wish they would improve upon. Indicate that it's something special to this signal. Anyways, enough chatting. We're going to grab this. On scan finished. Bang. Whoops. Got a little happy there with my copy and paste. Total. All right, so now we've hooked into this file scanner, and we've got the signals and slots all set up. Now we need to actually go into our button and say on clicked, scanner, scan, and you notice how it's not doing anything. So now we need to figure out why is that not doing anything. So let's go into our file scanner. Where's our scan? Ah, this is why. QML really only will let us work with signals and slots. So now we're going to have to go to a public and again, the difference between a public function and a public slot is just the mock's going to add in that meta object in the background, which allows us now to work with it in QML. So if I say scan, still not going to take it. Let's give it a good build. That little trigger might have actually done it, but let's give it a build. Now I can say scanner. Scan magically appears. There it goes. And it actually knows the function prototype, function scan path. So now I need to just say txt path text. Some of the little complexities of working with QML, you got a few extra hoops you need to jump through. But my gosh, the power at your fingertips. I mean, QML is just amazing. And the fact that you can now use C++ classes with it, oh my gosh, just the sky's the limit on what you want to do with this. Sure enough, there is our path. It's not super intuitive, but we could improve the interface if we wanted to. Hit scan, in, big number, see? Works as expected. So some things you need to be aware of right off the bat. Yes, you can reuse classes and signals and slots and threading through QML, but you have to do it what I call the QML way, which if we look at our scanner class, our file scanner, we had to have a property so we could get the path out of there, and we had to convert our scan function from public to a public slot. So the main takeaways here is anything you do in widgets, you can pretty much do in QML. You just got to know the QML way of doing it. And the same principle applies. If we were to update this QML interface some 57,000 times, it's going to really bog down this device, or I should say bog down the updating. And if we put this QML application on a cell phone or an embedded device and we try updating that GUI 57,000 times, I'm going to say it. At some point in the background, Qt's going to say enough, and it's only going to update a certain number of times. It's not going to be 57,000, but it'll try to paint as fast as it can. And that's going to chew up battery on that device, and it's going to chew up CPU cycles.